Alrighty, so now that we've talked about Pythagorean theorem, I'm going to show you something new that uses right triangles. These are called the trigonometric ratios. I suck at saying that word. Alright, so in order for these ratios to make any sense, we first have to talk about labeling a triangle. Not talking about labeling it A, B, C like we did with the Pythagorean theorem. We're going to use new words. Alright, so this new labeling style, one, you need to have a right triangle, and two, you have to have some sort of angle. So it depends, it will change how you label it if you're looking at this angle or if you're looking at this angle. So I don't know, let's look at that bottom one, okay? Let's just ignore that one. So first, if we're looking at the angle, the side across from it, so if this thing has eyes, it's a smiley face, the side across from it, as if it's checking it out across the street, we call that the opposite side. Alrighty. Now, the side across from the right angle, we already have the name for that. Okay, that's the longest side in the triangle. So if the right angle is looking across the street and he's checking out that big side over there, that one is called the hypotenuse. But you knew that already. And the third one is called adjacent. Adjacent literally means beside. Okay, the side touching the angle that's not the hypotenuse. So that would be this side here. Right? So in this particular triangle, the way it's set up right now, because we're looking at this angle, this side here is the adjacent, the longest side is the hypotenuse, and the side that it's looking at, that angle is looking at, is the opposite. Alrighty. And I'm often going to use those three-letter abbreviations. So, like I said, it changes depending on where that angle is. So all of these are right triangles, and this one has the right angle up there. I want you to label them if we're looking at angle B. Okay, so that means you're looking at angle B. So I'm just going to do one of them, you're going to do two of them. Alright, I'm going to do the middle one. So hypotenuse, always the longest side, and the one the right angle is looking at, so that's this one here. The opposite is the one that the angle we picked is looking at. So since we picked angle B, it's looking at this side down here. So that's my opposite. And my leftover is the adjacent. Right, so I want you to pause it, try the other two, and then make sure you have the same thing as me. Alright? So pause it, do them, and then unpause it. Alright, assuming you just did them, you should have answers like so. Alright, so this will be opposite, adjacent, hypotenuse. This one here, this will be opposite. This is my longest side, so this is my hypotenuse. My leftover side is my adjacent. Alright, moving on. If you have questions about this, stop and ask me right now. You need to have these first steps down pat for the rest of it to make any sort of sense. Alright, so we have three different ratios. The first of which is called the tangent ratio. And it is the ratio of between the length of the side opposite and the length of the side adjacent. It is comparing those two sides, the opposite side with the adjacent side. In a right triangle, that is. And we actually have a formula for this. So the way we write this is tan of whatever angle. So we actually use this fancy symbol there. That's called theta, and we use that for angles. So that is theta. That just means an angle. Right, so that equals the opposite side divided by the adjacent side. Right, so what that means is, if I was looking at, let's use this angle here, if this is my angle I'm looking at, that would take this side here and divide it by this side. Okay, just ignore that triangle for now. So that is the tangent ratio. So for example, use this triangle to determine tangent of 30. So I know that tangent of some angle equals the opposite side divided by the adjacent side. So now I'm looking for tan 30. So that means I'm looking at this angle. So I'm going to label my triangle. This is my opposite. That's my right angle. This is my adjacent. This is my hypotenuse. So now I'm going to fill in my formula. Tangent of 30 is my opposite side divided by my adjacent side. My opposite side was 12. My adjacent side was 20. So tangent of 30 is 12 divided by 20. So, calculator. 12 divided by 20 equals 0.6. So tan 30 equals 0.6. Now, what's cool about this is, on a calculator, you'll notice I got my sine, cosine, and tan button. Here's my tan button. So, this is what your calculator is doing. If I type in tan 30, it's picturing a triangle like the one we just did and doing opposite over adjacent. If you have it in degree. Tan 30 equals pretty close to 0.6. Alright? So, let this be a note to you. Put this on first slide here. Your calc must be in degrees. Must be in degree mode, not rad. Okay? Radians or rad will not work for this stuff, okay? Yet. We don't really even talk about that until grade 12. Alright, so figuring out tangent. Okie dokie. Next. Next one is the sine ratio. Again, it's comparing two sides of a right triangle, except this one compares the opposite side with the hypotenuse. Right? So, if this was my right triangle, and let's say we're looking at this side, this angle now, I want to label it. So this will be my opposite, this will be my adjacent, pardon me, and this will be my hypotenuse. Call this theta. So the formula for the sine, so sine of some angle, will equal my opposite side divided by my hypotenuse. And ready. So using this, so let's use this triangle to determine sine 55. So let's label the triangle first. So this is my angle I'm looking at. So the side across from it is my opposite. The side across from the right angle is my hypotenuse. And my other side is my adjacent. So now I'm going to write down my formula for sine. Sine of some angle is my opposite side divided by my hypotenuse. Let's get rid of this accidental stuff here. So I'm going to sub in my numbers. Sine of my 55-degree angle is my opposite side, which was 4, divided by my hypotenuse, which is 4.9. I can go to my calculator. So that's 4 divided by 4.9, 0.8. That is what my sine of 55 would be. If I'm interested in type it in as sine 55, I still get the same answer. Cool. All right, and my third ratio is called the cosine ratio. and it compares the length of the adjacent side with the length of the hypotenuse. NUSE, sure. So if I was looking at, let's use the side triangle for once. So I was looking at this angle here. Let's call that theta. Let's call this, that'll have to be the opposite, because that's what the angle is looking at. My right angle, that always looks at my hypotenuse. My leftover side is my adjacent. So the formula for cosine is cosine of some angle equals adjacent over hypotenuse. Right, and a quick little same example. Let's determine the cosine of 30. So this is my 30-degree angle. Let's label our triangle. So the side my angle is looking at is always my opposite. The right angle, it always looks at the hypotenuse. My leftover is my adjacent. So write down my formula. Cosine of some angle is adjacent over hypotenuse. Sub in my numbers. Cosine of 30 is my adjacent side, which was 20, divided by my hypotenuse, which was 23. So using this triangle, cosine of 30 would be 20 divided by 23. 20 divided by 23, about 0.87. That's an 8. 0.87. Right, so that's just a quick little explanation of what the formulas are. Alright, in my next video we'll talk about how to use them and what they're used for. Alrighty.